When I was little, my father was famous. He was the greatest samurai in the empire. He cut off the heads of 131 lords.
Hey everybody, Jerry Williams, aka Greater Sapien here. Thanks for stopping by. A little while ago, I did a short video talking about the tides and how the different tidal levels proved the oceans must be curved. Now, one of my biggest fans and Flat Earth cheerleader sent me a link to a video purporting to use math to disprove the Earth's orbit around the sun using the influence that the sun and the moon have on the tides as mathematical evidence. This video is presented by Shane St. Pierre, one of the people I was told is part of the Flat Earth A-Team. And he's presenting a mathematical proof created by Dr. Robert Bennett, a physicist and Catholic apologist who wrote, amongst other things, a book titled Galileo Was Wrong, the Church Was Right. Now, this video is an excellent example of how someone with a specific agenda can use accurate math to lie to an unknowing audience. The paper by Bennett, promoted as a banger by Shane, claims that the math shows what the accepted model says about the influence the sun and moon have on the tides gravitationally and through centrifugal force is wildly incorrect, to the point the model cannot hold, and the concept that the Earth orbits the sun must be discarded. So, let's get into Shane's video. This video is a walkthrough of a slideshow that begins by saying, there are abundant attempts to try to solve why the Earth's high tides occur when the sun or moon are at both the near side and far side. Also an issue is why the moon is more than twice as important as the sun in determining local tidal ranges. And here, Shane says something that's very telling about his own intellectual abilities. For most of his video, he's just repeating Bennett's claims without checking them. But here, he offers his own insight.
Of course, in their model, it's 400 times bigger, but 400 times further away, so it should be having a proportionate exertion of gravitational force.
He says, according to the heliocentric model, the sun is 400 times bigger than the moon, but is 400 times farther away, so the influence should be the same. Dude, only the diameter of the sun is considered 400 times bigger than the diameter of the moon. The sun has over 456,000 times the moon's volume, allowing it to have 27 million times more mass. Do you think modern science says the sun is 400 times bigger than the moon? Do you think modern science says gravitational strength has a 1-to-1 relationship with distance? Have you never heard of the inverse square law? Come on, people. These are your champions. Okay, back to the video where Bennett's paper starts to get into the math, stating, let's try to find the acceleration at points A and B with respect to the center of the Earth, O, due to only the gravitational influence of the moon and Earth, as shown in the figure. And this is the figure that the paper presents. We have two circles representing the Earth and the moon. Point A is a point on the far side of the Earth from the moon. Point B is a point on the near side. Point O is at the center of the Earth, the center of its mass. Point X is the center of the moon. R sub E is the radius of the Earth. Lowercase d is the distance from O to X, which is the orbital distance of the moon. Then there is the mass of the Earth and the mass of the moon as m sub E and m sub m, respectively. Acceleration to the right is considered positive. Later on in the presentation, the mass of the sun as m sub s and its distance is represented by capital D. Bennett derives a series of equations to calculate the gravitational influences of the moon and the sun at points A, B, and O, the differences between A and B with respect to O, and the combined influences of the moon and sun. The methods he uses are mathematically valid, but suspect. For example, he calculates the acceleration at point B using the acceleration caused by the Earth here, and adds to that the acceleration on that point due solely to the moon here. Solid physics here. No issues with the equations. However, if we are trying to focus on the influence of the moon and the sun, having the Earth's influence represented here needlessly muddles the equations. He does the same for the sun later on. Equally solid equations were used. Then he starts making derivations, which I found suspect, but that will come up later. Now, Bennett doesn't give a lot of reasoning for this process, so I thought I would look up Bennett's actual paper since there was a link in the video description, and maybe that could provide some insight. Regrettably, the link is dead, but on the website there's a link to a previous version of the paper. Shane is showing version 2, and the website only has a good link to version 1. Version 1 is narratively the same. It makes the same assertions and arrives at the same conclusions. But for some reason, the mathematical equations are very different. But it did give me the feeling that Bennett was experimenting with finding the math that would get him to his goal. That, however, is purely an inference on my part. All of this work was done to find the ratio of the moon's tidal influence compared to the sun's through this derived equation, and they arrived at a value of about 2.35, meaning the moon is 2.35 times more influential on the Earth's tides compared to the sun. Now remember how I was wondering why Bennett was going through all these derivations? Well, I was wondering because the process for calculating this ratio already exists. Yeah. First, we take the equation for the strength of a tidal force, which already exists. This says the force F is proportional to the mass of the celestial body m divided by the distance from the Earth d cubed. Take this equation for the moon and divide it by the same modified for the sun to get the formula Bennett came up with through all those derivations. Bennett, in his paper, seems to be proud of the fact that his derived formula for finding this ratio gave him a value that is in line with what experimental science has found, and Shane takes it as some type of achievement. I find that odd because Bennett's derived formula is precisely the formula physics uses to make these calculations. His formula is not novel. The formula is not his. He just made a lot of hand gestures getting to it, like a fake chef making a big show out of the prep only to pull a pre-made dish out of the oven. Oddly though, when I put Bennett's rounded values for the sun and the Earth's masses and distances, I got 2.19, very close to the experimentally found 2.16. I don't know where he came up with 2.35. So, Bennett has completed one of his goals, to show that the moon's tidal influence can be shown as greater than the sun's without bringing centrifugal force of the Earth's orbit into it. Goal achieved, I guess. The next thing Bennett does is calculate the centrifugal acceleration the sun causes on the Earth, but not the moon, saying the moon causes no centrifugal acceleration on the Earth's tides because the Earth doesn't orbit the moon. The moon orbits the Earth. Sorry, dog barking. But the sun causes the centrifugal acceleration on the Earth in the consensus heliocentric model. Of course, this is incorrect. In the consensus heliocentric model, the Earth and the moon orbit around their common center of mass, and there is a centrifugal acceleration on the Earth due to the moon. Gypsy, stop. Thank you. How many times do I need to say it, people? If you want to argue against the accepted model, you need to understand the accepted model. Your premise is false. But I will continue. Looking here, you'll see Bennett used a standard centrifugal acceleration formula to calculate the acceleration on the near side, far side, and center of the Earth. At least this time he didn't act like he created his own formula. The values Bennett uses are suspect, though. He says the value he's using for v is the average speed adjusted for the orbital speed variance due to Earth's elliptical path. That is just a lie. The average speed is already adjusted for the orbital speed variance due to Earth's elliptical path. That's what averaging does. The value that Bennett is using is the rotational speed of the Earth at the equator. This is supposed to just be the centrifugal acceleration due to the sun. The Earth's rotation should not come into this. Putting this variance is just bad science. Now, there is a difference in the orbital velocity of a point facing the sun versus a point away from the sun and the center of the Earth, but it is often considered negligible. Negligible, but calculable. And I took the time to do so. Here are the velocities. So, looking at these numbers, if Bennett is going to round the velocity of the center of the Earth to 30 kilometers per second, which is what he did, then all of these values should be 30 kilometers per second. And centrifugal acceleration at all these points would be effectively 6.0 times 10 to the minus third meters per second squared. There's no practical difference between these different points when we round that much. Just to be thorough, though, I did calculate the acceleration at those points using more precise values, and here are those results. Now, this is where we get to the big point of Bennett's paper and why people like Shane think it's great. Bennett then compares the centrifugal acceleration of the Earth due to the sun to the gravitational acceleration due to the sun he came up with through his unnecessary derivations by adding real values to his equations. The results say that the centrifugal acceleration due to the sun is nearly 12,000 times the influence of gravitational acceleration. Since that is obviously not true from observations, he concludes that this means the Earth must not be going around the sun. But wait, sorry. This is where Bennett is lying using accurate math. If we go back to the beginning, we'll recall that Bennett had put together a calculation of the sun's influence on a point on the surface that I agreed was perfectly solid, and then he started doing derivations. If we calculate the gravitational acceleration on Earth due solely to the sun using the agreed upon equation before Bennett made modifications, acceleration equals the gravitational constant times the mass of the sun divided by the distance to the sun squared. And we plug in Bennett's rounded numbers, we get 6.0 times 10 to the minus third meters per second squared, the exact same value as the centrifugal acceleration of the Earth in orbit, which is exactly what physics tells us should be the case. Action, reaction, balance of forces. The force that pulls the Earth toward the sun is balanced by a force in the other direction. The gravitational acceleration and the centrifugal acceleration are the same, but in opposite directions. Bennett's original, unmodified equation confirms what the consensus heliocentric model says should be the case. So why is Bennett's derivation different? And is that difference important? In order to answer those questions, I need to do a couple more calculations. The force of gravity due solely to the moon at points A and B on the Earth and the center of the Earth using Bennett's original unmodified equations. Those calculations come to point A, 3.219 times 10 to the minus fifth meters per second squared. Center of the Earth, 3.326 times 10 to the minus fifth meters per second squared. And point B, 3.5 440 times 10 to the minus 5th meters per second squared. While for the sun's gravity, we have point A, 5.93 times 10 to the minus 3rd meters per second squared, center of the Earth O, 5.9316 times 10 to the minus 3rd meters per second squared, and point B, 5.9327 times 10 to the minus 3rd meters per second squared. And then if we place actual numbers in Bennett's derived equation for acceleration due to the moon and sun, we get 1.1039 times 10 to the minus 6 meters per second squared for the moon's value, and 5.0396 times 10 to the minus 7th meters per second squared for the sun's value. So, those numbers are great, Jerry. What do they mean? First, I have to say that Bennett's derived equations about the acceleration due to the moon and due to the sun are valid equations. They already existed. He didn't create them. They are not, however, equations for the acceleration due to the moon or due to the sun. They are derivations to determine the acceleration gradient over the radius of the Earth due to the moon or the sun. They are equations for the expected change in acceleration across the distance of the radius of the Earth. That is, if you have gravitational acceleration at this point on the surface of the Earth and you have a gravitational acceleration at the center of the Earth, this equation will tell you what the difference between those gravitational accelerations should approximately be. How much should the gravitational acceleration change from here to here, and then from here to here? It's not how much acceleration should be, it's how much acceleration should change. This doesn't say that the sun has very little influence on these different points on the surface of the Earth. It says there is very little change in its influence from one side of the Earth to the other. In other words, the sun's pull on the tides on this side of the Earth is not much different from its pull on the tides on the other side of the Earth. The moon doesn't exert more gravitational force on these points on the Earth compared to the sun, but there's more than twice as much change in its force over the distance of these 2 points, and thus there is an imbalance of influence. You don't need to take my word for it. You can check the math. For example, take the acceleration at point B due to the moon and subtract it from the acceleration at the center of the Earth due to the moon, which will give you a number that represents the change in acceleration across the Earth's radius. That value will be approximately the same as the value generated by Bennett's derived equation. The same thing happens when you try it with the sun. I'm not going to do the math for you flat earthers this time. Do it yourself. You'll see that I'm right. Or don't do it and admit to yourself you're not willing to learn the truth. Rather than undermining the consensus heliocentric model, Bennett's equations, which were not his at all, have confirmed it. Bennett had to know what his equation represented when he made the derivation, but he didn't identify that and passed it off as an equivalent to the acceleration equation it was derived from. He lied because he knew he had an ignorant audience that would buy what he said. As a physicist, he should know better. But then again, he's a Catholic apologist, so having no shame is a pretty common trait. I don't know anything about Shane St. Pierre. I don't know if he's just a liar or just ignorant.
Bit of both.
A lot of both. But this video here, and the one I did about Whitsitt and his misrepresentation of Walter Lewin, are great examples of why I don't debate these people. I'm sure right now some of their fans are saying,
"Oh, but he would kick your ass in a debate."
They want to debate because in a debate they can freely lie and bring up misrepresentations or bad science from physicists that I've heard nothing about because I don't follow the trends of the flat earth mentality. And unless I can refute something on the spot, that goes on the ledger as something I couldn't respond to. A victory for the science denier. No, I prefer to critique claims the way it's done in the realm of science. Allow people to publish their claims, go on the record endorsing a position, putting their name, their voice, and their face behind it. I can then unpack their claims, check their sources, check their math, and write out a thorough response to their thoroughly flawed claim. No gotchas, no dunking, just checking your work. If you don't like it, you can kick rocks, or don't publish garbage science, or tell your fanboys not to send me links to your videos because if it wasn't for them, I wouldn't know who you are. And we'd all be better off if that were the case. I mean, I don't mind collecting another body, because
that's my job, that's what I do! I don't lose! I win! Is there no one on this planet to even challenge me?
Maybe you came by to congratulate me on last night's victory.